What's up guys, how's it going? So today we're going to solve the two-sum 2 problem. We have already solved the two-sum problem. You can check this video out. The link will be on the description. So before you solve the two-sum 2 problem, you should solve the two-sum problem. So the problem is that you are given an array of integers. It could be negative or positive, and you are given a integer target. I need to find the two number that will add up to the target number. So for example, here you need to find two number that will add up to 9, and the numbers are 2 and 7. You are guaranteed to have exactly one solution from the input array, and you cannot use same element twice, but you can have duplicate elements. So this is exactly same as the two-sum problem. But the change here is that the input array is sorted. Time complexity of the two-sum problem was O of n, and the space complexity was also O of n. And since the input array is sorted, you need to use constant space. You cannot use another data structure for the algorithm. And the numbers are actually sorted in ascending order, so the left numbers are smaller than the right number. So we can use a two-pointer method. So we can add a pointer on the left side and on the right side, and we can add them. So if the sum matches with the target number, that's great. We have the solution. Or the sum is bigger than the target number, that means that the sum needs to be reduced. So we need to shift our right pointer to the left to reduce the sum, because the left numbers are smaller than the right numbers. So we will be able to reduce the sum. And if the sum is smaller than the target number, then we have to move the pointer to the right, because the right numbers are bigger. So we need to increase the sum. And we will keep doing that until we get a solution. So let's run over this example. So the first two numbers are 2 and 15, and the sum is 17, which is more than our target number. So we need to reduce the sum, so we can move the pointer to the left. Now the sum is 13, still bigger, so we can move the pointer, the right pointer, to the left. And now the numbers are 2 and 7, and the sum is 9, which actually matches our target. And you need to return the indexes, not the number itself. Weirdly, the indexes has to be 1 base instead of 0 based. So that will be our solution. It's pretty easy problem. The time complexity will be O of n, since we have to loop over the entire array. And the space complexity will be constant, since we are not using any kind of extra data structure. So let's just code it up. It's going to be pretty easy. So let's create the pointers. Let left will be 0, and right will be the length minus 1. Now we can start looping. We can use a while loop for that. While, and the condition would be that the left has to be always smaller than the right. So it could be the case that the left and the right pointer ends up in a single number, and we don't want that. The left has to be always smaller than right. And let's get the number. And let's get the, it should be left number. It should be right index. Now let's get the sum. So left number plus right number. If the sum is equals to the target, we can just return the indexes. So left plus 1 and right plus 1. Otherwise, if the sum is bigger than the target, then we need to reduce the sum. So we need to shift our right pointer to the left. So right minus minus. Otherwise, left plus plus. So that should do the work. Let's run the code. And it has accepted the solution. So let's submit it. It should also work. And it is also accepted. So that's it for this video. If you have learned something new, don't forget to like, share, and subscribe to my channel. You can also check out my other channel, Cules Coding. The link will be also on the description. So that's it for today. Stay safe. Goodbye.